Myself Yogesh Jadhav from MIT Academy of Engineering. Today I am going to do presentation on implementation of FFT algorithm using DSP professor under the guidance of ma'am Professor Judhan Balsode ma'am. My group members are Satvik Devade, Vaibhav Moske, and Pratik Lagaskar. So here we go. So basically the fast Fourier transfer is called as a FFT. It is an algorithm which computes discrete Fourier transform and is inverse, that is IDFT. So the problem statement is to implement fast Fourier transform algorithm using DSP processor, and the objectives for this presentation are the to study the FFT algorithm and its properties, and the second one is to implement the FFT algorithm using dedicated DSP processor. So in our presentation, we are going to see the fast Fourier transform, its definition and introduction. Then we'll see Fourier analysis. After that, methods of decomposition in FFT, and then we'll see the FFT convolution, bit reversal in FFT, and at the last, we will see the implementation of FFT on DSP. So first, we'll see what is FFT. So FFT is the fast Fourier transform algorithm which computes the discrete Fourier transform, and it is used to obtain the decomposition, the sequence of representation into the frequency domain. That is, here we can see that uh, all the input that is in signal which are in time domain are converted into the frequency domain. It is the only uh, work of the DFT. So we can see here the samples are basically 16, and the samples are getting divided into two parts in each stage. Though, so the in first stage it is divided into parts, and then third stage it is further divided each one into straight parts, that is four parts, and at the last we can see that there are 16 parts. So overall we can see that the 16 samples are going to end in the 16 points. That is nothing but the FFT decomposition. Then we see this in the diagram. You can see that at the left side we can see time domain signals, and at the right side we can see the frequency domain signals. So FFT algorithm is used to convert the time domain signal into the frequency domain. So each signal is here we can see, you can see that each signal is of time domain is converted into the frequency domain. It's so this one is the bit reversal method of sorting in FFT. Basically, the bit reversal is, you can say that the binary numbers are going to convert in its mirror values. That is, in the first line you can see that 0 0 are the same for the, and for the you can see for decimal one equals binary equals is 0 0 1, and after mirroring or the bit reversal transformation, you can see that one is going to in the most significant bit, that is 8. In decimal 1 1 1 0 0 1 is going to 8. So in this way all the numbers are that decimal numbers are bit reversal, and in same for the binaries. So in this image you can see that as previous on the left side the time domain signals are there, and in the right side you can see the frequency domain. So in time domain you can see that uh, each sample is, in between each sample we are going to add zeros, and in the frequency domain we are just shifting the samples in the right side, and same for the another example. So this is the main part of the presentation: implementation of digital signal processor, that is a TMS3 2020. So you can see that this is the actual TMS3 2020, which is Texas Instruments, and this is the block diagram of this digital processor. You can see that there is memory and the data lines, memory address buses, and memories. So let's see now the buffer. this is the like input and output double buffering, which is used in this DSP processor. So buffer A, there is input x of n, and then we will get the its output, and same for the buffer B. And after combine this, we can see that the input and output is going to data channels. Now this figure shows the input output circular buffering for large FFTs. That is, for large FFTs there are so many samples, so we require this. So input output channels are this, and this is going to complex word circular buffer. And you can see that there is a input for a start pointer and the end pointer. So now let's see this. This is the on-chip memory to speed FFT execution. For the fast, as you know, FFT is a very fast algorithm, so it uses on-chip memory to speed up its. Let's see now the execution of 1024 point complex FFT on chip RAM. So as you can see that 1024 points are so much, so we are going to divide it into small parts using the FFT. So 250 complex points are 2024 are divided into 256 each, that is 4 points each. And here you can see that this is the memory, on chip memory. Now let's see the point diagrammatical representation of converting the 202 points into the 256 points kernel. You can see that there are from 0 to 2024 there are 1024 points samples, which are going to convert it into the output using the bit reversal method. So this one is the bit reversal stage, and we are getting the 1 to 8 stage here, and then 10 till 10 we will get the output. So at the last, I like to conclude my presentation. So fast Fourier transform is an algorithm that computes the discrete Fourier transform DFT of a sequence, or the IDFT. Fast Fourier analysis converts a signal from its original domain, often time or space, to a representation in frequency domain, and vice versa. So the DFT is basically going to convert the frequency time domain signal into frequency domain. So the DFT is obtained by decomposing sequence of values into components of different frequencies. This operation is useful in many fields. As a consequence, the DSP benefits from all the advantageous properties of FFT when implemented on a hardware. So here are some references from which I have made the PPT, and you can refer this implement references. Thank you.